So the instructions here are to use graphs and tables to find the limit as x approaches positive infinity and negative infinity, and then also identify all horizontal asymptotes. So the first function that we're going to look at is this function, sine of 2x divided by x. But it says to use graphs and tables. So I'm going to be using my graphing calculator for this. So I'll type in the equation right here, and then we'll continue on from there. So here I have my equation. So let's look at the graph of this first. And my window's all messed up, but I'll change that as soon as it's done loading. I'll probably zoom, fit, and then we'll see what it looks like. Okay, so this is the sine of 2x divided by x. And it's asking for the limits as x approaches positive and negative infinity. It looks like it's just circling around 0. So if I look at my table, well, I should go to the table settings. We can start it at 0, and we'll increment by 1, or by pi. Since we're doing trig stuff, I'm just going to use pi. Second pi. There's no real you can use anything you want there. We'll still be able to see a trend. Okay, so there we have that. We're going to set it to auto so it fills the table for us. And when you plug in 0, it's undefined because we have x in the bottom. But as we continue on, what happens? It just keeps repeating y values, but the y values are getting really tiny. They're oscillating around 0, and then it goes back and back. And these are just getting more and more small. If we can see, if we can see in our graph, it's just oscillating. So if it continues on, it's just going to keep getting closer and closer to 0, just oscillating around 0. So as we approach to the right, we'll get 0. As we approach to the left, we'll get 0. What if you didn't have a graphing calculator? You can go to wolframalpha.com and type in f of x equals sine 2x. Let's put that in parentheses. Divided by x. See what happens. Ask Wolfram Alpha to graph it for us. So we have this. That's great. And it tells us a whole bunch of information about it. And it should tell us the graph as well. Maybe. I think. Yep, there it is. And as you keep going out, you can possibly see that it's oscillating around 0, and it's getting closer and closer to 0, closer and closer to 0. You can actually say x from anything you want. So I'm going to change this, comma, x from, let's say, negative 100 to 100, right? Because that's from negative 12 to 12 or negative 12.6 to 12.6. Let's see what this does. And it just keeps oscillating like crazy, and it's just going and going and going and going and going and going and going. It'll just get smaller and smaller and smaller, closer and closer to those values. So yeah, there you go. It just changed the window from negative 100 to 100. It's going to get smaller and smaller and smaller as we go out there. What if we add another 2 zeros? I just want to see. But that's really that problem. Oh, and then it said identify all horizontal asymptotes. Well, we can see it just gets more and more dense. It's just going to keep oscillating around there, keep getting closer and closer and closer. So what is the asymptotes are, well, it's getting closer and closer. It does reach 0. Is this an asymptote, though? Well, we could think about the definition of an asymptote. If we look at the definition of a horizontal asymptote, is a line that the graph of a function approaches as the magnitude of the input as x increases goes to positive or negative infinity. It's just literally, the definition involves taking the limit as x approaches infinity and negative infinity. If it equals some number, then that's an asymptote. So yes, this does have an asymptote, and the asymptote is 0 because this just oscillates around 0 farther and farther and farther and farther and farther down the line. All right. Yeah, that's all for this video.